and the masters of the universe. I am Adam, Prince of Eternia and defender of the secrets of Castle Grayskull. This is Cringer, my fearless friend. Fabulous secret powers were revealed to me the day I held aloft my magic sword and said, "By the power of
pH! Off pH!
Cringer became the mighty battle cat.
Okay, enough of this. Okay, so today we're going to be talking about pH. By the power of pH, not Grayskull. Yeah, so there's a funny story about He-Man. He-Man was created by Mattel. It was about this guy. This guy had this sword, and basically all his clothes fell off, and he got really muscly. And every episode, it was like a super sexist show. He had to go rescue some girl because there's only a couple girls in the He-Man universe. And then I think people complained, so they made another show called She-Ra, not He-Man, but She-Ra, and she was the princess of power, and she rode a horse that got turned into a flying unicorn, and there's only a couple men in that universe, and they just gender swapped the script, so she had to go rescue some, guys that got into trouble. Anyways, He-Man's great show. Great show. Okay. pH stands for power of hydrogen, but we're going to say, whoa, that's the weirdest H ever. Ugh. Okay. Power of hydronium. And hydronium, remember, is the water that gains an extra hydrogen. Now, in order to figure out pH, you're going to have to use a button on your calculator called a log. And in order to calculate pH, it's a log base 10, meaning that every time you go up by a number, the factor increases by 10. And the irony is that if you're looking at any of the COVID-19 growth charts, the scariest part is the logarithmic growth. If a logarithmic growth is going up, that means it's increasing by factors of 10 instead of just like plotting on a normal y-axis. So the formula for pH is the negative log of the concentration of hydronium. Oh my goodness. So there's a lot to unpack here. Anything with brackets means concentration or moles per liter. So we don't have to write moles per liter. If you put something in brackets, in like the big thick boy square brackets. Now, that's how you calculate pH. If you know the moles per liter of your hydronium, you can throw that into the formula and it works. You can also go from pH to hydronium the other way by taking the inverse log or second function log of negative pH. Now, it's going to take a bit of time to practice this, and not everybody's calculators maybe has a log function on it, so you may not be able to do some of this at home. But this is part of Chem 30, so we're going to take some time today to go through some examples, and then after the break, we're going to review it. The pH scale, remember, goes with 7 being neutral all the way down to, I don't know, let's just say 0. You can have pHs less than 0. These are all acids, and these are all bases, right? This is the pH scale. Now, there's actually a base scale called pOH, which is the power of hydroxide. And the scale flips. Neutral is still 7, but less is actually a base. And higher is actually an acid. And that may take a bit of time to wrap your head around, because if you have a pH of 1, that's a really strong acid. But if you have a pOH of 1, you have a really strong base. The crazy thing is that both of those always will be equal to 14. Always. So if you have a pH of 3, your pOH has to be 11. Because if your acid is here then your POH is here, and they both add up to 14. Now, we're going to be doing some very simple questions, and we're going to leave the tough ones for after the break. Okay. Before we get... oh, man, this is where people in the class... I love teaching this when everybody's in the class because everybody wants to throw stuff at me, and you can't throw stuff at me from home. But the pH rules change... the sig-fig rules change for pH. Let's say we had a normal number, 3.11 moles per liter. If I said, yo, how many sig figs is that? Most of you would say, there's 3 sig figs, dog. And I'd be like, quit calling me dog. That's rude. I call my dog puppy. So if you call me a puppy, that's also weird. Just call me Mr. Zed. So there's 3 sig figs right there. If you had a pH of 3.11, this is where the anger comes, and you're just going to have to rage silently at home. This has only 2 sig figs. I pause for effect while you shout it at your computer screen. Why? Anything in front of the decimal is a log base 10 placeholder. It actually doesn't have any accuracy. It's only the digits after the decimal that count towards significant digits in pH. It's a little thing, and it's not the biggest thing ever, but the rule is different. So if you had a pH of 12.111, how many sig figs would that have? 3, because we only count the digits after the decimal. If you had a pH of 7, how many sig figs is that? 0. If you had a pH of 7.0, how many sig figs is that? 1. You count the number of digits after the 0. Now you have to be very careful. pH doesn't have a unit. There's no unit to pH. If you saw 7.0 moles per liter, that is not pH. That is concentration, and normal sig-fig rules apply. So screwy sig-fig rules apply for pH and POH, not for concentration. All right, so we're going to practice that in a couple questions coming up. All right. So we're just going to practice a few easy pH questions. Here's the first one. 4.5 times 10 to the minus 4 moles per liter of H3O. What is the pH? Okay. pH is equal to the negative log of hydronium. Now, on my graphing calculator, what I do to input this, I go negative 4.5. Oh, sorry, I don't do that. I go negative log 4.5, and then I go second function EE. And a little e shows up. And then I press negative 4. And then I press close brackets. That's what I have to put into my calculator, because by putting negative log, it kind of puts a little bracket there for yourself. It keeps the number separated. Now, if you put negative log of 4. Now, again, some of you at home, I'm not sure what calculators you have. That's like writing out this, right? 0.00045. So you can go negative log 0.00045. Anyways, when you put that into your calculator, if you take the negative log of that number, I want you to get a calculator right now. So pause this video, get a calculator, get your calculator app, take the negative log of that, because you have to get the same number as I'm going to give you, okay? All right, so hopefully you pause the video. I get 3.3, 4, 6, 7, 8, blah, 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 blah. Okay, that's the pH. Less than 7, this is acidic. Now, rounding this to proper sig figs. This is a real use of sig figs. So I've got to round this to 2 sig figs. So I have to round this to 2 digits after the number, because anything in front of the decimal doesn't count. So this would be 3.35, because the 6 rounds the 4 to a 5. That's the pH of 4.5 times 10 to the negative 4. Okay, let's try another one. Negative log of H3O gives me pH. So I'm going to take the negative log of 5.55 times 10 to the minus 9 moles per liter. Okay, negative log 5.55 10 to the minus 9. Okay, if I plug that into my calculator, I get 8.2555707 ... So what do I have to round this to? Well, this is concentration. Normal sig fig rules apply. I have to round this to 3 digits. This is pH. I only use digits after. So I have to round this to 3 digits there. This becomes 8.256 because the 7 rounds the 5 to a 6. This is greater than 7, so this is a base. All right. Now going the other way. Let's say I have pH and I have to find the hydronium ion concentration. So H3O concentration is equal to the inverse log of pH. Should put the formula in there. Okay, now how do you get inverse log? I get it by going second function log. So if I go second function log on my calculator, I get this shows up. I have a graphing calculator and a little tin with a hat and a bracket shows up. Now there's another way to do this I'll explain in a second. And then I go negative 4.59 close brackets. Okay. And when I throw that into my calculator, what do I get? I get a fairly small number. I get 2.5703 ... times 10 to the minus 5. Okay, now that's concentration because I've solved for something in brackets. How many sig figs? Well, this is pH, so I only include the 2 digits after. So I round this to 2 digits. This is concentration, so I use the first digit. So this becomes 2.6 times 10 to the minus 5 moles per liter. Okay. Now, there is another way to do this. You can actually go 10 to the power of minus 4.59. Okay, you'll get the same answer. So if you have a calculator, you can go 10 and then the little hat function minus 4.59. It works the same way. You'll get the same thing instead of pressing second function log. That works too. Okay. All right, let's try this last question. We're solving for hydronium ion concentration. So hydronium ion concentration formula is inverse log of pH. So I'm going to go second function log. Okay, I'm going to take the negative of 11.76. Second function log, negative 11.76. Okay. All right, now I'll just round this in one go. How many sig figs do I have here? This is pH, so the first digits don't count. I have to round this to 2 digits. So I get 1.7 times 10 to the minus 12 moles per liter. Okay. So what I've shown you guys on these 4 questions is how to turn pH into hydronium and how to turn hydronium into pH. Okay, I've got one more little slide to show you, and that's all we're going to work on today, and you're going to have some questions to practice this. And after the break, we're going to put some more stuff together. Okay, but that's good for today. Now, what is the extra thing I'm going to say? Well, pH is a base 10. So if we had a pH of 7, 6, 5, and 4, every time you change the number, you change it by a factor of 10. So 7 to 6, if this is an acid, 6 is 10 times more acidic than 7. If I go from 7 to 5, that's a change of 10 times 10. it is 100 times more acidic than 7. Every time it changes by 10. So that's why it's so dangerous if you get something with a pH of 1 on your skin. Because if we follow this all the way down, that's 10, 100, 1,000, 10,000, 100,000, 1,000,000 times stronger. That's why low pHs are so dangerous. And that's, again, if we were going up to 14, why very basic substances are so dangerous, is that it's a log base 10 change. We use pH because it's something easy for us to wrap our head around. If I say something has a pH of 5 and you know a little bit about pH, you're like, ooh, that's probably a lemon, sir. I would like that lemon juice in my water. Okay, perfect. But if I said don't drink that juice, it's got a concentration of 1 times 10 to the minus 5 moles per liter of hydronium, you'd be like, what are you talking about? So we use pH as an easy way to communicate the concentration of the molecule that has been made from an acid giving away its hydrogen to water. The power of hydronium.